right, so this is homework from 5.5. So number 4, I think many of you are done number 4 already, but let's just make sure that we're all on the same page on this one. So list the domain and range of the graph of each function. So these graphs have individual points, right, not solid lines. So we're going to be listing all of the numbers, okay? So for A, domain, I'll write it up here, capital D equals braces, okay? This is how I want you to write the domain and range. Capital D equals the brace there. And then you list the numbers because it's individual dots. So -2 has a dot. So -2, I'm going to write, comma. This is -1, has a dot. 0 has a dot. 1 has a dot. And 2 has a dot, and that's where they end. So close that off with the brackets. Okay? The range is are the y values. So, whoops. So think about the y values here. That's the horizontal. So this first point has a -4, and then this point has that would be a -2 there, and then a 0, and then a 2, and then a 4. Okay, so that's the domain and range for 4A. Any questions about that? Are we all understanding that? It's good? Yeah? All right. Okay, let's skip to number 6 now. I'll do number 6A here. So which of these graphs, actually I'll do both of them. Which of these graphs represent a function? Justify your answer. So we talked about the vertical line test, right? So if we can draw a vertical line at any part of the graph and it just touches the graph one time, then this is a function. Yes, this one is a function. Justify your answer. Passes vertical line test. You can abbreviate that if you want. Passes vertical line test. All right. Well, this one over here, this is a vertical line itself. So all of the points line up vertically. You see that? All the points that are on this line line up vertically. So this would certainly not pass the vertical line test because a vertical line touches all the points. So this is not a function. Okay? And it does not pass. Okay? Does not pass VLT. All right. Now, another thing that I want to mention, actually, any questions about that function test? No? Good. Another thing I want to mention here, and this is important, I think I touched on this in the lesson, but I'm not sure. And maybe it's coming next, actually. I'll talk more about it. But any horizontal line, like perfectly flat horizontal line, is always y equals a number. And that number is the number that it passes through on the y-axis. So it's y equals, there's no x term in there. The x term gives it a tilt, okay? It gives it a slant. So if it's perfectly horizontal, it's y equals only. And the vertical lines, they have no y values in them. It's just x equals. So vertical lines are always x equals a number. And this number, of course, is the number that it passes through on the x-axis. Okay? Now think about this. Most horizontal lines don't ever touch the x-axis, right? They're parallel. So that's why there's no x in there. You can think about it that way. Vertical lines, most of them, unless it's this vertical line right here going through 0, they never touch the y-axis, so there's no y. Okay? All right, so that's a little tidbit. I think we'll talk more about that maybe next section. But can I move on from 6? Yeah? Okay, 7. All right, it says match the graph of each function to its domain. I don't have them listed here. We're just going to write domain and range for these ones, okay? So these are dots that are connected. They're connected, so I do have to account for all of the x and y values that are represented on the lines that connect the dots as well. So domain equals braces. It goes from x value of 1 all the way through to x value of 4. So 1 is my low end boundary, the lower end boundary, and it includes 1, so I'm going to go less than or equal to x, and this is a solid dot, so it includes 4, so less than or equal to, and my upper boundary is 4. And again, if you're still kind of confused about why we would do it this way, you can think about it this way. All of the x values that are represented on this graph are greater than or equal to 1 if you read it from the middle, greater than or equal to 1. As well, these x values are also less than or equal to 4, so they're everything in between. Okay? Range, let's move to the range. Range is, again, you look at the y values here. So it looks like it goes from 1 all the way up to 2. So 1 less than or equal to y now, because the range is y values, 2. Okay, any questions about that one? No, everyone's good? Okay, 100%? Yeah. All right, and again, domain is from here, 1, 2, 3, and range is from 2 to 4. I won't take the time to write that one out there. All right, 8. Talked a little bit about 8 already, but let me go over this again. Which of these graphs represents a function? Yes, function, right here, because it passes the vertical line test. Anywhere you draw a vertical line, it only passes once. This, not a function, because this part does not pass the vertical line test, right? So not function. All right. Domain and range, we can still write domain and range for non-functions, so let's do domain and range for each. D equals, well, because this doesn't have arrows on it, but when the textbook has just a line that kind of like goes right to the edge of the shown graph, then it means it continues on forever. So this continues on forever up, these continue on forever left and right. This one has a clear point at the end of it, so it's a segment, so it stops. It's dead, it's done here. So the domain is x is an element of all real numbers. That means it can be anything. X goes forever left, forever right. To negative infinity, to positive infinity. The range here is not infinite. It's from 1, that's the low point here, you see, all the way up to 3 being the high point. So 1 less than or equal to y less than or equal to 3. And because they are solid lines there, 3 is included, 1 is included, I have the or equal to. Make sense? Any questions there? No? Easy? Hopefully this is getting easy. We've done this enough times. Hopefully this is starting to get easy. So domain here, again, for this one, is -3. It is included there, so less than or equal to. We were talking about x values in domain. Less than or equal to, it stops here, right? At 1. So that's the domain. Range, okay, now here's range. This is tricky. It starts at -1. That's the low point, and it continues on up forever. So the range is y is greater than or equal to -1, and that's all you need to put. If there's no upper boundary, then you can just say greater than a certain value. Okay, you'll notice in the textbook, I think in the textbook I saw once that they did not have these braces. Okay, they didn't have the braces, that they just wrote like this, I think. I think I saw that somewhere. Okay, so let me just say that I'm the boss, not the textbook. Okay, all right, I'm going to be teaching you math for a few years here, and I know what's going to be expected, so I want you to do the braces. Don't say, oh, the textbook doesn't have them, I don't need to do them. No, Mr. Maxwell says you have to do them. Gotcha? So again, I'm trying to train you to be very good math athletes. Okay, this is good practice for you. So yes, please use those braces, like this. Any questions about 8? Okay, I think maybe, I got 12 too, so let's do 9 real quick. I'll do 9, 8 anyways. Determine domain and range. Okay, again, this should be pretty easy. Notice that this is like those arrows keep going. So domain is everything left and right. This goes up forever and left forever, up forever and right forever. So x is an element of all real numbers. And for the range here, it looks like there's a minimum at 1 and no maximum. So y greater than or equal to 1. Capiche? All right. This one, range from -3 to +3. Sorry, domain from -3 to +3, range from 0 to +3. All right, 12. This is the last one in your assignment. How many of you have done number 12? Have you done number 12? Okay. A few hands. How many of you are working on number 12 currently? How many of you are not at number 12 yet? Okay, you're on 11? Okay, I'm going to give you a few more minutes before I do this one because I want you to have a chance, but I will, I'll help you with this question in about 10 minutes. And there's the whole question if you want to see that all in one screen, and go ahead and give that a try. All right, so number 12 says, when police officers investigate a car crash, they can estimate the speed the car was traveling by measuring the skid distance. So the skid marks on the road, here's a little picture of them, skid marks on the road. If they're short, the estimation was the car was going not that fast. If they're really long, the car was going faster initially, and there is a bit of a graph that represents this. So if the police officers do not know how fast the car was going at the moment of impact, but they can see some skid marks, then they have a good idea. Let's say the skid marks are 80 meters long. That seems like quite a long 80 meters. Wow, that is actually very long. Then it appears that the car was going about, I would say, about 85? No, 90? What is that? So this is 100, so that's about 90. About 90 kilometers per hour. Okay, now, is that really meters? Okay. 80 meters is a long time. That's skidding a long time. I don't know if I believe that, to tell you the truth. But yeah, at 80 meters, that's a long time. Okay. I would guess, either those brakes are really bad, or...
When you slam on the brakes, it locks up, and then the tire would wear away. I know it would just be easy, but...
Yeah, no, I know, but 80 meters still seems like a very long time.
A little much, yeah.
That's a long ways down the street. That's a half a block, like almost, in some little parts. I'm like, okay. Anyways, let's just go with what's given. Okay, I think that's a little long, but anyways. Like 40 kilometers an hour, that's like barely a school zone, a little over a school zone, and that's going to be a 20 meter skid mark. 20 meter skid mark. Okay, 19 meter skid mark, whatever. All right, so that's not the point. The point is not how goofy this graph is, but the point is, A says, why are the points in the graph connected? So why are they not separate dots apart from each other? Why are they connected? So this is good for you to think of and be able to verbalize. So what would your answer be? And don't give me the answer that's in the back of the book either.
Don't they
What's your words?
When they're like continuous and you can have measurements in between.
Yes. Okay, that's excellent. That's what I would expect from you. If the measurements are continuous, so if the situation provides continuous measurements even in between plotted points, then you should connect them. Okay? There are many examples of that, like when time goes on and you're measuring, distance that you're walking. Well, each fraction of a second, you're at a certain distance, so you can plot every little tiniest fraction of a second connected. This one, as the speed increases, every instant in time the speed increases will have a distance of a skid mark, every instant in time. So it's not like, it jumps from this measurement just to the next measurement with nothing in between. So if there are no points in between certain plotted points, then it shouldn't be connected. But why are they connected? It's a continuous situation where each speed provides a distance of skid. Every speed conceivable within the domain provides, again, that's pretty technical stuff, but that was put well. It's continuous, and every single point, every single speed that's listed here would have a corresponding distance, and so you could connect all the points because it's a continuous situation. All right, estimate the domain and range of the graph. Are there any restrictions on the domain and range? Well, of this graph, it looks like the domain is from 40 to 120, okay? From 40 kilometers an hour to 120 kilometers an hour. That's what the domain is. The range for this graph looks to be about maybe 18 or 19 to about, was that 142 maybe? So maybe 19 to 142 for a range on this particular graph. Would there be restrictions? What kind of restrictions would be on the domain here? What parts of the domain are not possible, do you think, or not reasonable?
Going above 120 kilometers.
Well, okay, so the graph doesn't show anything above 120 kilometers for skid mark, but do vehicles go over 120?
Yeah.
They do. So that 120 wouldn't be a limit of the range, but that's I'm glad you said that, because that's a good point. That's what people would, I think that's what a lot of people would say. Now, there would be a restriction way up here probably. Like most cars can't go 300 kilometers an hour, right? So you might say it's got to be under 300 kilometers an hour because most cars can't do over 300 kilometers an hour, right? And obviously there's a limit down here. 0 would have to be a limit, right? You can't be going a negative speed.
Could you go in reverse?
Negative velocity is directional. Negative speed is not possible. So velocity includes direction, which plus and minus can give you the different directions. But if it's just speed, and again, speed is technically a scalar quantity, velocity is a vector quantity, so that means velocity is direction, but a negative speed doesn't really make any sense. It's like you can go 0, but that's as low as you can go for a speed, okay? So yes, you're talking about velocity, which is directional. So I mean 0 to, maybe somewhere around 300 kilometers an hour maybe would be a reasonable restricted range. And then skid marks here, well, skid marks, you can't have a negative length for skid marks, right? Ooh, look there's skid marks that are not there. That's negative 1 meter of skid mark. No, you can't see that. So obviously skid marks from 0 meters. And then we don't really know where it ends here, but you could probably, it's not going to go infinitely, right? Like it's going to, these skid marks are probably going to level out somewhere just because of gravity, because of, friction, because of the way things work. So anyways, I don't know what you might want to put for a top. It looks like maybe you want to say 200 or 300 meters would be probably near the top if we're talking about 300 kilometers an hour. So what you could do too, though, is you could kind of extend this graph if you want, because to get to 300, you're going to be going into like thousands of meters. So if you did that, you'd say, well, that's not really reasonable. It's going to level out here somewhere, right? It's going to like kind of level out. So again, there's no specific right answer for this one, really, for this last part. But I want you to think about reality, right? Skid marks don't go on for many kilometers. Doesn't matter how fast you're going. Right? Something's going to happen. You're going to stop. So this is not going to increase indefinitely, right, in this pattern. But, okay, any questions about that or any thoughts? All right. Those are some long skid marks there. I don't know. All right, any questions about any of the homework? Anything from 4 to 12 that you were assigned? Nope.